And thank you all for coming to this session. My name is Ray. I'm a developer advocate for Google Cloud Platform. And very awesome to be able to join GFL this year. And what I do at Google, I do quite a few things. Number one is that I like to bring some of our technology to Java developers. I love Java. I've been a Java developer myself for a very long time. And so for that reason, I also internally help to make our Java development stories better. So I help the product teams to make sure that they support the Java development story really well. And I'm one of the person who started off this Spring Cloud GCP project. So if you ever use Spring with Google Cloud with some services, check it out. Just a bunch of starters that you can use. And just yesterday or the day before, we announced the App Engine for Java 11. So if you want to learn more about that, you can find me after the talk. Anyways, you can find me on Twitter at Satanism. Ask me any questions there. Direct message me, whatever. And if you want to find more information about anything I talk about today, or even more in depth, you can go to my site, which is satanism.me. And aside from technology, I love to travel. I love to travel all over the world. I love to be a backpacker. This photo is very special to me. It's me in the middle of the desert. And you might be asking why. I was backpacking many years ago in China, and I came to the city where I couldn't find a cheap place to stay. As a backpacker, I wasn't gonna spend hundreds of dollars on just a hotel. And so I asked around, and I say, hey, where can I go? Where can I stay for the night? And two random strangers told me, I can take a bus, I can go to a desert, and I can walk in the desert for 4 hours in the southwest direction, and I can find the oasis, and then I can stay there for free. And I heard the word free, and I asked, what bus do I take? Has anyone here hiked in the desert before? There's usually some people, yeah. By yourself in the middle of the desert? There's usually 1 or 2 people. But you all walk on the beach, right? Walk on the beach? Yeah, it's not the same. It's not the same as the desert, no. There's nothing, 2 hours into the desert, there's nothing in front of you, nothing behind you. You cannot see anything besides sand. And when somebody tells you to walk in one direction for 4 hours in the desert, you go over anything that you see, you just go in one direction. Right? So in this picture, you can see that there are these sand dunes up and down, so you actually have to go over these sand dunes. Otherwise, I might miss the oasis by a few degrees of angles, and I wouldn't be here today. And every step that you take, your foot sinks a little bit into the sand because the sand is really soft. Then you got to pull yourself out, and you got to take another step up the hill and down the hill, up and down for the 4 hours, basically. All of this time, I was like, this is my vacation. What am I doing this? It's hot, it's dry, I'm thirsty, it's so tiring. It feels like writing a J2EE application back in the days, something I tried to get away from, and it's like, what am I doing here? But the truth is, the end is beautiful. This is where we want to get to. The end is really beautiful. This is actually the oasis. I forgot whether it's sunset or sunrise. They all look the same. But it's beautiful. This is where we want to get to. And this is, the way I think about it is that this is the beautiful place that all of us want to get to when we are writing some applications, deploying into production. That's the beautiful place we want to get to. We want people to use our products. However, the road to the production environment is always very difficult. And it's like trekking through desert sometimes. And it takes a lot of time and patience to get through it. And so to that end, I think one of my job is to help you to get to the beautiful place much easier and faster, and hopefully you don't have to do the difficult stuff like I have been doing through my past experiences. So anyways, today I'm going to talk just a little bit about the project I've been working on internally with a internal Alphabet company, and I've been helping them for the past couple of months in terms of adopting technology like Spring Boot, and also Kubernetes and microservices architecture, and taking them all the way to prod, pre-prod. And the project has been very fun. So the high level, this infrastructure looks something like this. Of course, everything here on the environment is running on Google Cloud. But we set up the Kubernetes cluster with private networking. We have to control ingress and egress through through proxies and load balancers and NAT. And then we lay down Istio for service mesh to help us run our microservices and so on and so forth, right? And one of the most important things here that we have done is, of course, make everything as infrastructure as code. So we codified everything. In this case, we use Terraform. And everything that you see here is actually Terraformed. Everything from the infrastructure, the VPC, the networking, the firewall, whatever, the load balancer, it's all Terraformed. But then we also laid down like the Let's Encrypt, Istio, and other things within Kubernetes as well. So basically, what we wanted to get to was a place where we will be able to provision infrastructure, all codified, and then just leave this empty space where we need to fill in the code, right? This is the space that we are ready for deployment, okay? And that was pretty difficult to get into a production environment. So for local development, so I'm going to talk about today, is how do we do local development more effectively, as opposed to having to bootstrap all of these things locally, because a lot of these production concerns is not what we need to start with for local development. So there are a lot of different ways to do development with containers locally. Some people use Docker Compose. This team, they wanted to stay closer to Kubernetes. And so they're using local Kubernetes clusters and Skaffold and things like that. I'm going to go into detail later, okay? However, we are also avoiding some of the production level infrastructure. So for example, Istio, we're running this in production environment. And staging and all the higher environments. But for local development, it would just, it'll be maybe too much to just install and run. And so for local development, we just try to use something simpler, like Envoy proxy. So that will get us to the point where we can make a request and see it on the site, and that's really it. In local development, we're not really concerned with all of the other production concerns at this very moment. And all of the other dependencies that we need to use, like Postgres, Kafka, and stuff like that, we just run containers in an ephemeral way so that we can deploy everything in Kubernetes and local Kubernetes environment, and then we can test against those as well. I think long story short, we're really trying to focus on just the empty part here, where we want the development team to be able to focus on the code and be able to iterate fast. And that's really the key. One of the things that I think that we learned is that a lot of times we try to make our lower environments the same as production, right? And sometimes we carry this all the way to development. So say, hey, your development environment has to look like production. Otherwise, you see all these issues that you can only produce in production environment, but not in your local. But I think that's just, that's just the way it is. Because in production, everything's different. It's just very hard to get that exact same environment down to the development environment. As much as we try, I think it's just gonna be a huge gap. Because more complexity that we pull down, the more difficult it is to be productive as a developer, right? And there's just a lot more to learn. So for local environment, we really try to focus on productivity, right? We want to make sure that new members who join the team can get started quickly and can get the code and start developing very quickly. And we need to focus on the design of the application and not necessarily to be too concerned about where this app is deploying to. And so I think that for me, it's really that when you're designing your app, you really just want to design your app the right way. And it doesn't really matter what the runtime environment is. Because, yesterday was machines, the day before that was, VMs or whatever. And then the day after was, maybe like PaaS, CF, or Heroku. Right now, we're talking about Kubernetes. Who knows what next 5 years, 10 years this will be. So always focus on your app. Because if you design your application properly, then you can probably deploy to any of these environments, either back then and now and in the future, very easily. So I would highly suggest, in this case, we focus on 12-factor app. How many people here heard about 12-factor apps? Yeah, about half of the room. If not, I definitely check it out. Now, how many people here who raised their hand implemented all 12 factors? Yeah, wow, I don't see anyone. Maybe there's one. 5? 5 factors? Not even 5. Yeah, there are a few. 1. You gotta have 1. Everyone here should have 1. That's the reason being that in 12-factor, the first factor is you checking your code. Okay, so everyone here should have at least 1 factor. So hopefully you have that. But if you look at this list, this is all very much just designing your app. Dependencies need to be declared and isolated, and configuration should be externalized. Services should be stateless. You should be able to listen on the port that the environment wants you to listen on. Logs should be centralized and stuff like that. Like everything here are things that you would otherwise want to have in apps anywhere you deploy it, right? So focus on the app first. The second part of it is that we try to stay away from Kubernetes as much as possible in local development, and at least this is what I also found in other teams where I talk to them and say, hey, do you like Kubernetes? Do you don't like Kubernetes? Every person who says that they like it, they do this religiously. They do local testing. Everything that they do is tested locally with unit test. They just do Maven test or integration test, and just make sure everything is tested locally. This is super, super useful. You don't want to run in any environment until you have tested your code in the unit testing environment. And then, if you are depending on other services, then make sure that those services are mocked. Maybe you need to use some kind of like contract testing as well with Spring Cloud contracts. But if you need to depend on something that's external, like for example, PostgreSQL or Kafka, something that is not, you cannot just easily run a startup in a unit test with Java, then you can use something called test containers. So this is really useful, where you can just spin up a container as part of the unit test. You can use that container for the life cycle of the unit test. And then when your unit test is done, you will shut it down, and everything is ephemeral, so you can make sure that you can always test against the real environments, right? So for example, like running a test against H2 database might be very, very different running a test against a PostgreSQL database, right? And if your environment is actually using Postgres, maybe you should test against that, in which case you can use test containers to help you to bring down Postgres and bootstrap it really, really quickly. And then, of course, we adopted the microservices architecture, and one of the first questions that people ask is, how do I check in the code? Like, what is that structure of the code repository? And the fundamental question people ask is, do we do a mono repo, or do we create a multi-repo? Okay? So mono repo is where you put all of your services into a single code repository, and whenever you check in, right, and you build everything. Multi-repo is where you probably separate them, and now you need to know how they are interrelated a little bit better. Fundamentally, this is the way I think about it. Am I building a distributed monolith in a mono repo? Right? Even though the services are distributed services, but they have tight coupling. Or am I building a real distributed service, right? And that's how people relate to mono repo versus multi-repo. However, the decision is not as easy as this, because I think overwhelmingly, I think that the multi-repo in microservices world is definitely really, really good. There are a lot of pros and cons between the two repository style, and we have to pick one. We all have to pick one. I don't know, 2 days ago, I gave a talk in Den Bosch. I think half of the room was using mono repo, the other half was using multi-repo. I'm pretty sure it's similar here. But we have to pick one, but we pick one potentially not just based on which one's more superior when we go, go like say 2-3 years from now, right? Because the service is going to be long-lived. But we pick one based on, well, what can we do today, and then how do we hedge against changes in the future, right? So for example, in the mono repo, it's very easy to get started. All you have to do is to create a new repository. You dump all the services in there. If you're using Maven or Gradle, you do a multi-module, multi-project structure. And then you say Gradle build in the top, and then you build everything, right? And then if you need to update one of the libraries, update one of the common code, then you just update it, and then you just run build again, and then everything works, right? Everything's up to the latest version. Testing is easy too. You just Gradle test or Maven test, and you test everything in one shot. Even CI/CD is easier because you just need one pipeline. In a mono repo, you just got one repository, so you just have one pipeline, and it builds everything for you, right? And initially, the velocity is really, really quick, right? Because you just have to deal with one thing. In multi-repo, the story is quite different. Now we have to deal with one project per repository. Now, if I have 3 services, I got to get 3 repositories, and I need to make this thing scalable somehow. Because every repository that I make, how do I make sure that they're using a version of Spring Boot or a version of some dependencies that we actually really want you to use? Then we end up having to create some kind of dependency management tools, like using bombs and using Maven parents to make sure that we have the right dependencies. However, then now this parent or the bomb would become yet another repository, yet another project you have to manage. And then how do you actually manage these artifacts that you have not in the mono repo? If you have multi-repo, all of these artifacts will have to be stored somewhere in a central repository, like Artifactory or something else, right? So now you need facilities to run and operate a Maven repository, right? How do we do that? How do we keep them up and running? And then if you need to do like a testing against the latest version, you might be testing against snapshots. Is that is that something you want to test against, right? How do you make sure you have the latest version of everything? Because snapshots can be flaky. So as you can see, there are a lot of other issues with multi-repo that will take a lot of tooling to help you to resolve, right? CI/CD. If just doing a pipeline for a single repository, it was hard, try to do that for 10 repositories. It's even harder, right? So there are a lot of these things, and it's really hard to get started in a really good multi-repo environment. However, in the long term, I think that multi-repo definitely is better. We're already start to seeing like the constraints of Mono Repo, right? Every time I modify a service, I have to rebuild the whole thing because it's really hard to determine how this service rebuild or how this library rebuild trickles down to other services. So when you release, you might be releasing the whole thing as well. And that kind of defeats the purpose of a true microservice architecture. Okay? However, we chose Mono Repo anyways. Right? There's a lot of benefits in both, right? And there are cons in both. So the reason we chose it is because the team who came from Google engineering, right? We use Mono Repo internally, so we're very familiar with how Mono Repo operates. It was really, really quick to on-ramp the development teams and to make sure that they're productive on almost day one. And partially, it's also because we didn't have existing infrastructure. We don't have a centralized Maven repository. We don't have all these dependency management tools. If we update a dependency, like do we have a bot that help us to update the version? We didn't have any of those, right? So to make a true multi-repo environment, we need a lot more tooling than what we currently have. However, we did anticipate that we will move to multi-repo in the future, right? Just because we know we will outgrow the Mono Repo that's in Git. So we hedge our bets, against that, and say we need to make sure that in the future that whatever we do in Mono Repo in the future we can split it, okay? And we have already successfully been able to do that, right? So the decisions here is really based on not just the technical decisions, but also other factors as well, like what the team is already capable of, and other risks. So the project structure now looks like this. We have a project, we got the common build, and then we have services that is well defined and separated. When we depend on, if we have inter-module dependencies, we make sure that we use Gradle to depend on the projects so that we can then easily switch out into a Maven coordinate later. Okay. And really, like, I don't think there's a bad choice. It's just about how well you can adapt to a different choice in the future. So make sure that you hedge against those changes. And it really just takes really good design in your application and the way that you lay out your repositories. Okay. For service-to-service communication, we are, typically people will pick between REST, gRPC, and something else, right? They all have their pros and cons. I talk about gRPC quite a bit. And we chose gRPC just because we're Google. No, well, gRPC is a Google project, and the true reason is this. It's two parts. One is that, again, engineers who are working on the project is very familiar with the internal tooling called Stubby, and so gRPC is a natural tooling that they can adapt really, really quick. But the second part of it is that gRPC, you define the contracts, you define these payloads and services and signatures upfront and early. So that everybody from the different teams or everybody from the team can see this file and understand exactly what the payload should look like. And also that this will also generate all the stubs for you. So you never have to write a POJO and then kind of figure out, oh, did I map this field right to the right field in the JSON? No, like in gRPC, everything is just statically generated for you. All you need to do is to consume it. So we generate both the objects for the message and also the service stubs so that you don't have to guesstimate like where the code should be and also what the payload should look like. Everything is generated for you. And we generate this not just for Java, but potentially for other languages. In fact, we also generate the same, using the same stubs, we will generate this for JavaScript so that we can call the services directly from our front end as well. We also use the same messaging of protobuf messages, even in Kafka messages, right? So that we know we have consistency in our message format. And then these proto files, these definitions, we also have to decide where and how we store it, right? So for example, there are two trains of thought. One is to store all of these service definitions and messages that we defined in a single directory, okay? And now they are tightly coupled. Or we store all of these things in separate services so that there is a separation of concern. And this type of thinking, again, goes back to Mono Repo versus multi-repo, right? Do you want something together that's tightly coupled that when you change one thing, you have to redeploy everything, right? Or do you want something that's just loosely coupled and you have clear separation between them? And of course, because we knew we might move to multi-repo later, it doesn't make any sense to put all the proto files, all of these declarations in the same directory. And so we put all of these declarations under the service that they are supposed to be using, right? So in auth, we would have the auth proto, and the user would have user proto, and so on and so forth. And later, when we separate these repositories, it will be a very, very clean cut. Okay? And then also to, again, hedge against these issues, right? We would we'll create the .proto file, but then this is also the file that we distribute to other consumers, right? So even though we can generate the stubs, we can generate these messages as Java objects, but we don't distribute those Java objects. We actually just distribute the proto file so that the receiver of the proto file can then use the same definition and regenerate the objects however that they need to, right? So in this way, we can also distribute the proto file to the front end, and they can also then generate the JavaScript bindings to the actual service. So in the app, we're using Gradle, and we just produce another classifier here called proto. And when we're consuming it, we just consume this with the protobuf plugin, and then we reference the proto-specific configuration, right? So this is pulling the proto and not the jar. And later, when we split these services out to a multi-repo, we can just replace this line with a Maven coordinate, and it will still work the same way. So this is how we make sure we can separate. Now, gRPC in Spring Boot, there are many, many different starters. The support level is so different, and you just have to kind of pick and choose your own. However, they all have the similar challenges. So for example, the proto files, we generate the proto objects. They're not POJOs. Okay, so they're not POJOs. So what that also means is it doesn't work with any ORM frameworks like Hibernate or JPA, anything like that. And so we still ended up having to write some additional things that will convert the payload from protobuf into a regular POJO so that we can persist it into the database with ORM. Spring security, like all bets are off. There's not a real good integration there, so we have to write our own. Bean validation, if you're using GSR 305 or anything that you use on the REST payload, none of those things work on the proto-generated file, and so we have to do validation manually. And now there's a really cool project that helps you to do that. It's called proto-cgen validate. Okay. And then from the front end, because we're using gRPC, we don't need to translate that into a JSON, RESTful service at all. We can just convert that straight to gRPC-Web. The reason for this is because the browsers don't usually support HTTP. They support HTTP2 protocol, but they don't usually support the full spec. Specifically, they don't support trailers. We know headers, we know body, but trailers is something specific in HTTP2 that gRPC actually needs to use. And so most of our browsers cannot just make gRPC code natively. And so we need to transcode this into gRPC-Web, which is really just, you do this over the regular HTTP protocol as opposed to a full gRPC protocol on HTTP2. Okay? And this transcoding can take place either automatically by using the Envoy proxy or Istio, or if you use some other project like Armeria, this is really, really cool, then you can multiplex gRPC, HTTP1, and HTTP2 protocols all on the same port. So what we're doing is we're using gRPC natively, and we're just transcoding from the web, using gRPC-Web into just gRPC. Okay? Now, in the production cluster, in the higher level clusters, we're using Istio. Istio has transcoding built in, so in Istio, we just configure it to say this port is a gRPC-Web port, then it will just add the transcoding for us automatically. But for local development, we're not using Istio, and so we're just using a simple proxy, and we add transcoding there for us. However, we do want to use Istio in a higher level environment because the team really needed mutual TLS. They needed traffic routing, transcoding, monitoring, and trace, and egress, whitelisting, and control, circuit breakers. All of these things we just offload to Istio so that during development, we don't really have to deal with these things at all. And we can deploy the same application into this Istio environment, and automatically it gets all of these benefits, which is really nice. But we're not using Istio locally, partially because it can be too complicated. And if something goes wrong, the more that you bring down from production into local, if something goes wrong, then you have to be a production engineer to understand how to debug and troubleshoot it, right? And it will take a lot of time to learn all the layers. It will take a lot of time to figure out what actually went wrong, right? So, so locally, we just want to make sure everyone can just develop very quickly. Okay. In Istio, the very quick way to enable gRPC-Web is just to name it properly. Just call it gRPC-Web something, and it will just work. Okay. And you can learn a lot more about this in other, like gRPC and Istio in my other talks. But the learnings here is really just keep your development environment simple, even if you're using Kubernetes. Try to make sure that they can be split into a multi-repo fashion in case you are doing Mono Repo. And just keep the service themselves simple and offload as much as you can to the infrastructure when you can. All right. And then finally, for containers, for here, really, I have another 1-hour talk just about how to build a container properly using a Docker file. There's a lot of things you have to consider, but today I'm going to say forget about all of those things, just gib it. How many people here heard about gib before? Yeah, some people in the room. So gib allows you to build a Docker container with all of the best practices that I mentioned earlier in the previous slide in a 1-hour talk, down to a single Maven plugin or Gradle plugin, and just helps you to build a container very quickly. You don't even need to write a Docker file. This is great. The one thing that you need to be aware of is choosing your JDK, because some older version of the JDK is not container aware. What that means is that if I were to run my Java application in an older version of the JDK, like in this case, let me zoom in a little bit, zoom in. And I'm using JDK 8U141, so that is the one that is not container aware by default. So even if I run my JVM in a container that has 256 megabytes of RAM, if I don't specify any max heap, it's going to infer what the max heap should be. And in this case, the max heap should be 1/4 of, or a half of 256 megabytes. However, the max heap here is way, way bigger. This is actually 27 gigabytes of heap, right? And this will definitely exceed the 256 megabyte constraint. Because the JVM will see I got 27 gigabytes of heap, and will use up as much as I can before I garbage collect. And very quickly, you're going to see this weird message that reads OOM killed, right? And that's partially the reason why. And so if you're running this in a newer version of the JDK, 192 and above, I think, or I got 222 right here. Let me find the right one, 222. Yeah, why not? So let me just show you the memory here. I'm going to grab for max heap. This one will be proper. So this one will understand that your container can only use 256 megabytes of RAM, and then it automatically infer that you can use about 132 megabytes for the heap. Okay. Of course, you should definitely just figure out how much you need and configure this properly. On the top here, you see that I also have this weird additional arguments. This is really neat because JVM needs to use both the heap and the native memory. Mostly, if you give your container 256 megabytes of RAM, you cannot just give it 256 megabytes of heap, because your native memory will use up a lot more than 256, or you use more than 256 as well. So your JVM size is actually the native memory usage plus the heap usage. But it's not very easy to always figure out what those are. And so if you really want to understand it, you can run it with the native memory tracking. What this will do is, upon the exit of your Java application, it's going to do a breakdown for you. Only on a successful exit, okay? So if you exit your Java application successfully, then this is going to give you a breakdown of how much heap is being used, like Java heap, and then how much native memory is also being used, right? And so this will give you a really good idea of how much real memory you actually have to assign to avoid those out-of-memory issues, okay? And if you want to estimate even better, I would highly recommend using something like the Cloud Foundry build-pack memory calculator. So using this calculator, you can just give it the number of threads, the number of classes, and a few other parameters. It will tell you approximately how much memory your application may actually need to avoid these OOM issues. Right? Again, you can learn a lot more of this in some of the other talks in even more detail. Okay? Now, finally, after you design your app well, after you have all of the best practices applied to your containers, and after you got your your JVM right, then finally you can maybe want to test this in Kubernetes. And how do you actually do that? Well, again, we really wanted to do everything locally. There's always an argument between, well, should you use a centralized cluster that you can share? So you can create a cluster somewhere in your organization, and everybody just deploy into that. And you can separate who's deploying based on the users and the namespace, which is really neat. You can definitely do that. And for us, we tried both, and I think that the developers really enjoyed the local development experience. So we are, they started off with Docker Compose because it was really easy, and then we turned everything into Kubernetes because it was just way too different from the regular Kubernetes and the way that I operate. So even though it was really easy to get started, we eventually just started to install local Kubernetes environment. And so for local environment, I want to see how many people here use a Mac? About half the room. Yeah. Anyone use Linux? Linux, yeah. So you're definitely in luck. So if you're using Linux, then you can run Kubernetes environment in your local machine very, very easily by using something called K3s. Okay. So this is something I really like a lot as well. Basically, you just need to run through this command line. Very safe, very safe. Yeah. Run anything as root in your local machine. I don't know if it's really safe, but I do this all the time. Don't quote me on this. and then you run through this, and from nothing, from your computer that has no Docker and no Kubernetes, this will install everything for you in about 30 seconds. So this is one of my favorite local Kubernetes environment that I have found. Okay, that's really, really cool. If you're in Mac, mostly you might be using Docker for desktop. But then also consider this other one, which is called Kind. So what Kind is doing is that it allows you to create a Kubernetes cluster directly in your Docker daemon. So if I have no Kubernetes right now, I can run Kind. I can say Kind create a cluster, and this will run against my Docker daemon. And in my Docker daemon, it's going to provision Kubernetes for me. It's going to start up the Kubernetes master, make sure you have the right versions, and then give you the credentials, and ultimately give you a file that you can then use to connect to Kubernetes, right? So this is also another really, really easy way to set up Kubernetes cluster. Kind is actually also being used for integration tests. So if you ever need to test anything locally, or like in a CI/CD pipeline, you need to test your stuff with Kubernetes, rather than running against a real cluster, you can just spin up a Kind cluster temporarily, and then deploy all of your stuff, and then shut it down later. This is super cool. Okay. So that's what we're doing. We're actually running Kind in our environment today, and then we start doing our development. So this is the type of things that we do today. These are all the things that we have been adopting. Just want to make sure I'm good on time. 35 until 25. So I got like 20 more minutes or so. Okay, so this is what we can do. So this is a regular Spring Boot app, and I'm using IntelliJ here. And we have a little plugin called Cloud Code. This is a pretty cool plugin coming. Google created. And you can find this in IntelliJ, and you can also add this to VS Code if you want to. But what this will give you is Kubernetes support. And what does that mean? That means that, well, first of all, you get a Kubernetes Explorer, so you can see all of your clusters. I got lots and lots of clusters. And you can go in there, then you can start to explore your clusters. You can get logs and stuff this way. I still prefer the command line myself, but a lot of people like to go through the UI. The other thing that you get is ability to use something called Skaffold, okay? Because typically what happens in a regular development cycle, this is what happens. First of all, we need to create a YAML file for Kubernetes, so we would probably do something like make dir KAS, and then we will create a YAML file so that I can deploy this into my cluster. And the fastest way today to create a YAML file is something like this. You do kubectl, create a deployment. I'm going to code this demo JFile, for example. And the image is, I need to create an image. So let me go ahead and do that. So the image, the fastest way to create an image is by using gib. So in this case, I have used gib here to specify that I want to create an image from this Java project. And this is the image name I want to push into. This is pushing into Google Container Registry, specifically. And in this project, I can just do something like Maven compile, and gib build. Okay. And what this will do is this is going to analyze your Maven build, and it's going to understand your dependencies, your resources, and your actual code. And it's going to split them into 3 different layers so that when you change the code, you only change the layer that has the code, so you don't have to push 70 megabytes of container every single time. But just like that, we built the container. It's really, really easy. No Docker files involved, and super awesome to use. I really, really like this a lot. And then once you have the name of the container image, then you can do something like kubectl, create deployment. I'm going to code this demos/-gFo, and then the image is that. And then rather than running this as is, because this will actually run against my cluster, I'm going to add a little flag here called dry run. And this will just simulate the deployment. And then I can output the YAML file, and this is one of the easiest way to get the YAML file out of a deployment, right? And then now you don't have to write it yourself, basically. And then now you can pipe it to my KS directory. I'm going to save it as a deployment.yaml file, okay? And similarly, I can create a load balancer, a service, using exactly the same way. So what I can do is I can do kubectl, create service, cluster IP is an internal load balancer for demo gFo. And then I can say I need to listen on TCP port 8080, and then forward to port 8080 as well. And then remember dry run, and then OYAML, right? And then I can pipe this to my directory as well. So here we have KS service.yaml. Cool. And now I can go ahead and deploy. So I can say apply F, KS, and this will deploy both of the YAML files into my cluster. And it's always better if you generate the YAML file. I cannot stress this enough. If you're ever using Kubernetes, do write the YAML file and check them in, because then you can recreate the entire environment very, very easily. Okay. So then we have the service up and running. So I can say get pods. So we have the service. And then we have the thing called the service gets SVC. And I can see that I have a demo gFo service up and running, right? So if I connect to this endpoint, now I get my traffic routed to the pod. And then what happened is I need to connect to this remote endpoint. It's running the Kubernetes cluster, and the IP is local to the cluster only. And then what people usually do is to open a pull forward. So you open up pull forward, SVC, demo gFo, like that, the name of the service. Okay. And then you can bind it to the local port. I'm just going to say 908090, whatever, to the remote port 8080. And this will open up the proxy for me. So I'm tunneling through the Kubernetes master node. I'm able to get to the service, and then I can actually test my application in the cluster. And if I were to open up a new command line here, I can do curl localhost 8090, and hope this works. Hello, name is equal to Ray. ZSH, I have to quote this. Yeah, there we go. And then and that should go to the load balancer, and then whatever, right? And this is how typically people do this. And then if you find a mistake and say, oh, wait a second, I want to add a question mark or another, or maybe a period, then what do? We gotta go back to here, like plus like a dot, and then you go back to build a container, and then you reapply the files, you delete the deployments, and then you try to establish port forwarding again, and so on and so forth. This whole thing gets very, very repetitive. And so what Cloud Code can do, and another tools in combination of it, what we can do is to create a file called Skaffold. Okay? So there's a tool called Skaffold that helps us to iterate this cycle very, very quickly. So I'm going to go ahead and create a file called scaffold.yaml. They're all YAML files. And luckily, there is a little template I can use. And first, in this scaffold file, what I can do is to specify the image I want to build to. So even though I specified this in gib, but I need to specify it again. If you don't write anything else, this will just read the local Docker file that's associated with this directory, and it's going to be able to push and create this container for you automatically, right, using the Docker file. But because we're using gib, I can use the gib builder. So here I can add a specific configuration for gib. In fact, I can even pass in additional configuration here. Maybe it's called args. And usually, this is what I usually do. You should not do this at all, but I'm going to do this all the time. Yeah. Oh, that test that we just wrote, skipped, right? And then we can say, where are my Kubernetes files? I'm going to say, this is in KS directory, where I just generated. And these are the YAML files I want to deploy. And then what happens is that from the command line, I can just do something like scaffold def. And then maybe I want to pull forward, so I'm going to turn on pull forwarding as well. And what this will do is to run through all the things I just did manually. It's going to run Maven, compile, and then use gib to build the container, and then deploy the YAML file, and then even stream the logs to me as if it was local. And also, because I added the port forward argument, it actually established the pull forward for me locally too. So now, even though this is running in a Kubernetes cluster, I can do curl localhost 8080, I think. Hello, name is Jeffo, something like this, right? And this is doing exactly the same thing I just done manually, but all automated, which is really cool. And then if I see, after I do unit test, I still found some other issues in this whole integrated environment, then I can go back to my code. I'm just going to add a dot here, so I'm going to say dot space and save. And Skaffold is going to detect this change, and then rebuild the application for me, right? And then rebuild the container, and then redeploy the YAML files. And then now I can go ahead and fix the things and do the test too. Now in the IDE, we also have a similar experience here, so we can do run on Kubernetes continuously. In fact, if I were to shut this down, I can even run this in debug mode. So in this mode, what this will do is to do exactly what I've just done, but also enable the debug port. So now, from IntelliJ or VS Code, you should be able to debug your app as if it was running locally on your machine. And this is super useful when you're trying to troubleshoot something in a fully integrated environment, right? So for example, I can add a debug endpoint here, and I think if I do a curl again, no, it's not 80, it's not 8090, maybe it's 8080. No, I can't type today. 8080, yeah. And it's on, and you can see that the debugger got triggered, and now I'm debugging. Even though this is running remotely, we're still doing everything locally, which is really, really neat. And finally, of course, this is just for dev. This is really nice. For higher level environments, we need to make additional configuration changes, right? So for example, maybe I'm not going to be running just one instance anymore, because right now my replica here in my deployment, I have just one instance running. In QA or a test, maybe I need to run 2 instances just to make sure everything is working fine. But of course, we don't want to end up with just multiple copies of the same file. Okay? So what we're also using is another tool called Kustomize. Okay? Kustomize is another tool. And with this, you can specify a customization file. So what I'm going to do real quick is to just create a directory called Kustomize instead of KS. And then I'm going to create a directory called, maybe called base. This is the base deployments I want to make. I'm going to just copy things over, and then later I'll delete it, right? But right now, I'm just going to make a base, okay? What this is really just a packaged, a set of YAML files that I know I need to use as a template that I need to modify later, okay? And in this base, what I also can do is to add a customization.yaml, okay? And in this customization YAML, I need to add customize. And you might be wondering, where did this auto-completion come from? Kind is customization. This is all coming from Cloud Code, so the editor has really good support for all of these different type of YAML file that you can use. In this customization, I can specify which files do I want to be able to customize. So I want to do deployment.yaml and service.yaml, okay? And now if I go back to this directory, if I go to customize, go to base, I can run something called customize build. And what this will do is to go through that list of files I want to deploy, and will generate everything for me into just one output. And what people usually do is to output this to another YAML file. You check that in, and this is the thing that you deploy. Okay, that will be the source of truth for the actual deployment. Now, how can you use this? Well, if you are going to go into QA, then you can create another directory here called QA. And then you can also create another customization file as well. So I'm going to say customization.yaml. And you're going to do the same thing, like API version is customized. It's really nice for this to be auto-completed, right? And then I can say resource. Resource is going to be coming from the base, so I don't have to re-declare everything again. So it's going to inherit everything from the previous directory. And then I can start to do my patches. I can change things. And this is actually called a patch. What does that mean? Well, maybe I want to change in QA environment. I want to just change the section for replicas, right? So I can create a little patch here. So patch replicas.yaml. And what do I patch? Well, I'm going to patch this file, this deployment file. I'm going to patch this one. I'm going to change the replica to a different number, okay? So in the patch, I can just say, this is going to be keyed by API version, the kind, and the name, and nothing else matters in this case. And then I want to change that replica to 2 rather than 1. In customization file, then I can say, I just want to patch this. I'm going to use the patch merge strategy here, and I'm going to patch in the replica.yaml. So what this will do is this is going to read through the base files that we created, right? And then apply this patch based on the key, which is the combination of your API version, the kind, and the name, and then only modify this one field. So if I come back here to QA and say customize build, what you're going to see is you're going to see exactly the same files, except that in the QA environment, the replicas has been created, right? And you can use this for many, many other things. Now you can patch things, right? For example, I can write a application.properties file, properties. And then here I can say greeting is equal to hola, something like that, very small, but you see what I'm saying. And then in customization, I can say, you know what? In QA, I want to configure my application with the application.properties that's here. So I can create a config map. So I can say, here's a new config map, and this is called the demo config. And then the content of this is coming from application.properties, okay? And then now you go back to the QA environment, do a customized build. Not only do you get the deployment that's patched, you also get the service that's already there. But if you scroll up a little bit, you get the config map. And now you can start to mix and match all of these things so that your QA environment is now using the configuration that you really want to use, okay? Now, of course, everything that I just showed, we're actually using all of these things today. Everything I just showed also works really well with Skaffold. So here, rather than using the KAS directory, I can just switch this out to customize directory under base. Oh, sorry, I need to replace this whole thing. So this is customized. And the path is, path, oh man, here we go. Path is customize/base, okay? Now, of course, for QA or for some other environment maybe you want to test with, what you can do is to create a profile. So I can say, you know what, I want to create a new profile here called, just like Maven, you have profiles. Here we have profile too. So I have a profile called QA. And to deploy, I also want to use customize to deploy. And the path is customize/QA. Okay? And now if I run Skaffold, I can pick and choose which profile I want to use. So for example, here, if I want to do this in my IDE, I now can choose between the 2 different profiles. So you can test out different patches. Let's try QA and apply and run. So I'm going to run this continuously in the loop. And this will use customization for QA. So naturally, this will start up 2 of my applications as well. So if I go back to kubectl command line, if I see get pods, I should see 2 instances rather than just 1, right? So this is pretty much what we do for all of our environments, all the way from dev to staging to test and production. We customize our deployment files in the same way. Another note is that the customization, maybe you might want to just keep the base in your application. And the actual deployment to other environments, you can separate that out into a different directory for this case. Okay? So yeah, so we talk about Skaffold, Kustomize. One of the things I may not have time to talk about is liveness and the readiness probe. These things are super, super important. I just show you what that may look like. So for example, this is super, super important. So, as Kubernetes starts your app and shuts down your app, you have to figure, Kubernetes and your app has a contract. The contract is, I want to shut you down, and you need to say, OK, let me shut down gracefully. Or Kubernetes starts your app, and you need to be able to say, yes, I'm ready to serve the traffic. Or you might want to say, I'm having trouble, I need to be restarted. So all of these things you can specify from the probes. So for example, liveness probe, you can specify HTTP GET, and then the port, usually you do the same port that you're serving from, and the path is hello, maybe name is health check, or something like that. You have your own health check. And then for the readiness probe, you will probably do this with an actuator instead. But we can just go ahead and set this up separately. In my other slides, we have a lot more detail about how to properly do this readiness. Okay? And here, as soon as I save, again, Skaffold is going to see it. You can see that this is doing the deployment, and it's going to apply your changes in your development environment fairly quickly. Okay. So that's pretty much all I have. I just want to close off with just one last note. The road to production is pretty hard. So all the things I showed you, that's just for dev, right? And you saw all these other pictures around dev environment, and that's the road to production. You have to deal with VPC, NAT, egress, auditing, and security policies. One last note is that if anything that you need to worry about in your local environment is security. Just make sure that you write secure code, and also your container environment is also running the secure environment as well. And for that, you need to run not as root, but as a regular user, and a few other practices. So check out my slides for that. Okay. So with that being said, thank you so much for your time. And if you have any questions, I'd be happy to answer later in the room. Okay. So thank you so much.